right, so welcome to the A.REI.3 Level 2 video. This time we are going to be solving equations and inequalities with variables on both sides. So a tip, so that way we're on the same page, a tip is to move the variable to one side of the equation first using addition and subtraction. We should never be multiplying or dividing a variable over. So number one, we're going to first move the variable over to one side. It does not matter whether we get the x over to the right side of the equation or whether we get the negative 3x over to the left. It is completely up to you but we do want to get one of the variables or the variable to one side. I'm going to get the negative 3x over to the left side. Since it's a minus 3x, I'm always going to use addition and subtraction to get the variable over to one side of my equation. So I'm going to add 3x to both sides. And this is really a 1x here. So a 1x plus a 3x is a 4x. And then I have a minus 6 is equal to a 14. A negative 3x plus a 3x is a 0. It cancels out. So now this looks like a level 1. We've done these types of equations before, so this is nothing new to you. We're going to add 6 to both sides. I'm going to have a 4x is equal to a 20. And then I'm going to divide up by 4 on both sides to get my solution, which is x is equal to 5. If I put 5 back into my original equation, I could check to see if my answer is correct. So you can get 100% on these tests by just checking your answer. All right, number 2, we either need to get this plus 5s over to the right side, or we need to get this 7s over to the left first. Again, we're moving the variable to one side of my equation. It does not matter which side of your equation you move the variable to, but I'm going to get the 5s over to the right side. To get that 5s over there, I'm going to subtract. We always use addition or subtraction to get your variable moved. So now I have an 8, and then a plus 5s minus a 5s is a 0, that cancels out, is equal to a 7s minus a 5s is a 2s, and then minus a 2. Now this is an equation with a variable on one side. We've done these before. I'm going to add 2 to both sides. So an 8 plus a 2 is a 10, and that equals a 2s, because a negative 2 plus a 2 cancels out to 0. And then now I'm going to divide by 2 on both sides to get s is 5. Now, number 3, you are more than welcome to find common denominators here. I'll show you 2 different ways to do this one. So for number 3, we're going to get the variable on one side. Again, I'm showing you 2 ways to do this problem. Getting the variable on one side, you can either get the 2/3 x over to the right or the negative 7/5 x over to the left. I'm going to get the negative 7/5 x over to the left by adding it to both sides. Unfortunately, I need a common denominator here. And between a denominator of 3 and 5, I'm going to have a denominator of 15. That's my common denominator. To get a denominator of 15 on the 2/3, I need to multiply the numerator and the denominator by 5. So a 2 times a 5 is a 10. A 3 times a 5 is a 15. So I have a 10/15. To get a denominator of 15 on my 7/5, I need to multiply my numerator and denominator by 3. So I wind up with a 21/15. So a 10/15 plus a 21/15 is a 31/15 x. And then I have a minus 6/7 is equal to a 14/3. All right. So now I'm going to add the 6/7 over. Oops. 7 6 is 6/7. And I need to find a common denominator between those 2 numbers now, which I'm going to end up with a 31/15x on the left side, and then on the right side, between a denominator of 3 and a denominator of 7, what I can do is I can get a denominator of 21. To get a denominator of 21 on a 14/3, I need to multiply my numerator and denominator by 7. So 14 times a 7 is a 98. So I have a 98 over a 21. And to get a denominator of 21 on a 6/7, I need to multiply the numerator and denominator by 3. So I wind up with an 18 over 21. And a 98 over 21 plus an 18 over 21 is a 116 over 21. All right, now that 31/15 is not, or is being multiplied by x. So typically what we would do is we would divide by 31/15. However, that's not what we're going to do here, because we should never, ever, 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 ever divide a fraction by something. So instead of dividing by 15ths, we are going to learn how to multiply by the reciprocal. Dividing by a fraction is the same thing as multiplying by its reciprocal. So instead of dividing by a 31/15, we're going to multiply by a 15/31. That is the reciprocal. The reciprocal is when you flip your fraction around. And so a 15/15 cancels out to a 1. A 31/31 cancels out to a 1. And I'm left with an x is equal to, and I'm going to show you something cool. A 21 and a 15 are both divisible by 3. And since the 15's in the numerator and the 21's in the denominator, we can simplify that. A 15 divided by a 3 is a 5, and a 21 divided by a 3 is a 7. So now I'm going to do a 116 times a 5 to get a 580. And now I'm going to do a 7 times a 31. The denominator is being multiplied by one another to get a 217. And this is your answer. Or I did say I was going to show you a different way to do this problem. So actually from this step here, where we have a 31/15x is equal to a 116/21, what you could do is you can take care of the 31 divided by 15. You could take care of that division of 15 and simplify and have this be a 31x is equal to, now simplify the 15/21 because they're both divisible by 3, so that's a 5/7. So now we do a 116 times a 5, which is a 580, and then over a 7. And then now to get rid of the 31, instead of dividing by 31, we're going to multiply by a 1/31. So you could have done that in 2 steps. So you wind up with x is equal to now a 580 over, and then a 7 times a 31 is a 217. It's up to you on what you wanted to do there. But notice I multiply by the reciprocal both times. All right, so now we're going to learn proportions and how to solve proportions. So proportions are 2 ratios, which ratios are essentially fractions. 2 fractions equal to one another. And how we solve proportions is we use something called the cross products property. What that means is in number 4, this is a proportion because we have a fraction set equal to a fraction. This would not be a proportion. 3/4x plus a 3 is equal to a 1/3. That's not a proportion because your entire left side is not a fraction or a ratio. So this is not a proportion. But number 4 is, because we have a whole fraction set equal to a whole fraction. The cross products property states that we take the numerator of my first fraction and multiply it by the denominator of my second fraction. An x minus a 7 times a 3, we need to multiply the 3 by the x and by the minus 7, so we get a 3x minus 21. And then we write an equal to sign, and then we take the denominator of my first fraction multiplied by the numerator of my second fraction. A 4 times a 3x minus a 4, we need to multiply by the 4 by the 3x and by the minus 4. And this is now an equation that we've been dealing with. we want to move the variable to one side. So you either need to get the 3x over to the right side or the 12x over to the left. It's up to you, but we use addition and subtraction to do so. I'm going to subtract the 3x over to the right. So the 3x minus the 3x cancels out and I'm left with a negative 21 is equal to now a 9x minus a 16. Now this is a simple equation that we've seen before. We're going to move the 9 and the minus 16 over to the left side to move it away from the variable. But I'm going to want to add 16 to both sides first. I need to do it in a specific order. So a negative 1 plus a 12 plus a 16 is a negative 5, and that equals a 9x. And then now I'm going to divide by 9 on both sides to get x is equal to 5/9, negative 5/9, sorry. That is my answer. All right, so moving on to inequalities now, we're going to do the same exact thing. So number 5, I want to get my variable on one side first. I can either add this 3x over to the right, over to the right, or subtract the 2x over to the left. I'm going to subtract the 2x over to the left because I want to show you something. You can do it whatever way you want, but I want to go through this way. So a negative 3x minus a 2x is a negative 5x, and then plus a 4, which will be less than a 2x minus a 2x cancels, and I wind up with a 4. Now I'm going to subtract my 4 over, and I wind up with a negative 5x is less than, and a 4 minus a 4 is a 0. We're not just going to cross off the 4's because we do still need to have a number on the right side, and that number is 0. Now I'm going to divide by a negative 5 on both sides, and now hopefully you can imagine why I wanted to go through the problem this way. Because when I divide by a negative number, we cannot forget to flip my inequality symbol. That rule still does apply. A 0 divided by a negative 1 is a 0. So my solution is x is greater than 0, and now we're going to graph that solution. So I'm going to fill out my number line. Remember, the numbers increase as you go towards the right. They decrease as you go towards the left. And now since I have a no equal to sign, then I'm going to have an open dot on 0. And this reads x is greater than 0, so I want to shade all the numbers on my number line that are greater than 0, which means I'm shading to the right. All right. Looking at number 6, now you can go through number 6 like how I did number 3. You can find common denominators, it's up to you. Or let's actually get rid of all of our fractions. If you multiply an entire equation, every single term in your equation by a number, then it doesn't change the value of your equation, but between the denominators of 7, 2, and 4, all of those denominators are factors of the number 28. So let's multiply this by 28 over 1. Because what's going to happen now is all of my fractions are going to disappear, and it's going to be nice for us to work with. 28 times a 3/7 is going to be an 84/7 x. And now I'm going to have you go through and just multiply all your fractions by a 28 over 1. Now all my fractions were multiplied by 28 over 1. Now watch what happens. An 84 divided by a 7 leaves us with a 12x. A 28 divided by a 4 leaves us with a 7. And a 28 divided by a 2 leaves us with a 14. And a 140 divided by a 7 leaves us with a 20. Now the value of this equation did not change, but what happened was all my fractions disappeared. I'm going to have you try to solve this equation from this inequality from this point on. Pause the video, please. All right, this is your answer. Notice my number line, I just went 7 30-seconds, 8 30-seconds, 9 30-seconds, and so forth. If you wanted to solve this inequality like we did number 3, you're more than welcome to do so. I just wanted to show you a different method of solving. We're going to now move on to number 7. We're not going to finish it, but the cross products property, we're going to do the x plus 6 over 5, which is which is that, and then we keep our less than symbol, and now we do the other one. Now solve it from here.